In June of 1816, farmers in the Alps looked up at slopes that should have been green and saw winter sitting there intact. Fresh snow clung to the ridgelines. Meltwater ran cold through fields already beaten flat by rain. In parts of Switzerland, church bells marked summer, while people moved through a landscape that looked postponed, as if the season itself had failed to arrive. At Lake Geneva, the sky darkened so abruptly that candles were lit in the daytime. Across Central Europe, rivers swelled, roads softened, and grain blackened in the ground. Summer was on the calendar. On the land, it was missing. The accepted explanation is straightforward. In April of 1815, Mount Tambora erupted in Indonesia with extraordinary force, driving ash and sulfur high into the stratosphere. Those particles spread around the world, dimmed sunlight, and cooled the planet. By 1816, Europe was living under the after-image of a distant explosion. That account is not false. It is supported by geology, by ice cores, by temperature records, and by what observers later understood about volcanic aerosols. The timeline fits. The physics fits. The official explanation has the shape of an answer. And yet, when the European record is laid side by side, the event begins to look stranger than a bad summer caused by a volcano. The cold was real, but so was the darkness. The rain was relentless, but so were the sudden frosts. Harvests did not simply come in late. In many districts, they failed under skies that witnesses described as dull, veiled, metallic, or wrong. Grain could not move because rivers flooded. Prices surged because roads failed, fodder failed, and fear moved faster than carts. The disaster did not appear as one clean climate event. It arrived as weather, hunger, disease, unrest, migration, and administrative confusion at the same time. So what exactly was Europe experiencing? There is a more serious possibility in the record. Not that 1816 was caused by something mysterious instead of Tambora, but that the disaster has been remembered too narrowly. What happened may have been a continental atmospheric emergency whose true scale disappeared because it was filed away under separate names: bad weather, poor harvest, local famine, typhus, riot, relief, migration. The hidden pattern is not a secret plot. It is a fractured archive. What remains suggests that Europe did not merely endure a cold season. It passed through a temporary change in the sky, one powerful enough to distort agriculture, transport, public order, and memory all at once. Start with the mechanics. Tambora was not a routine eruption. It was one of the largest in recorded human history. Its plume reached into the stratosphere, where fine particles do not simply wash out in the next storm. Sulfur dioxide became a veil of sulfate aerosols that could persist for months and even years, scattering light, cooling the surface, and altering circulation far from the volcano itself. This matters because Europe's summer depends on balance. Atlantic airflow, pressure gradients, ocean heat, seasonal storm tracks. A small reduction in incoming sunlight can become a much larger disruption once winds and rainfall shift with it. The violence began on an island in Indonesia. The consequences arrived in Europe through physics, not rumour. Then there are the measurements. Long instrumental records from places like central England, Prague, and other early European stations show that 1816 was not remembered as unusually cold by accident. In parts of Europe, it was among the coldest summers in the record. July, which should have consolidated the harvest, became a month of wet chill and crop stress. Documentary evidence from the Czech lands describes an extremely cold summer followed by bad grain yields and price increases. In Switzerland, rain fell with such persistence that the season lost its structure. It did not behave like a sequence of ordinary storms. It behaved like a locked pattern. The record is still there. Numbers, parish notes, weather journals, and price tables all point in the same direction. The sky itself became evidence. Witnesses across Europe described dim sunlight, lurid sunsets, in a strange haze, and an atmosphere that seemed filtered through dust or smoke without the usual smell of fire. In London, the sunsets after Tambora were unusually brilliant. In parts of Hungary, snow was reported with a brown tint. In northern Italy, red snow was observed. These details sound ornamental until they are read for what they are: surface clues left by altered air. People in 1816 did not have the modern language of aerosol optical depth or stratospheric sulfate loading. They wrote what they saw: veiled sun, wrong-colored snow, noon gloom. The stone remembers. So does the sky, if the record is read carefully enough. On the ground, the agricultural pattern is even more revealing. Cold alone does not explain the full scale of loss. European farmers were dealing with wet fields, delayed sowing, rotted roots, flattened grain, and repeated interruptions in transport. Major rivers flooded and interfered with navigation, including the movement of grain at the precise moment food needed to circulate. This turned local crop damage into regional scarcity. A district with mediocre yield could not easily support a district with collapse because the water, the roads, and the markets were all under strain together. That is why the crisis appears in ledgers as price shock as much as weather shock. Oats rose, bread rose, fodder vanished, horses weakened. Movement itself became more expensive. What changed was the explanation. Later accounts often remembered the cold. The people living through it remembered the system failure. The public order record shows the same pattern. Food riots broke out in parts of Europe. Governments restricted grain exports. Authorities feared panic and, in some cases, suppressed or minimized news of poor harvests. Relief came late and unevenly. In Ireland, the wet and cold contributed to disease and wider social stress. In Switzerland, flooded rivers and failed harvests created streams of people moving in search of food and charity. None of this requires a dramatic conspiracy to understand. Bureaucracies respond to categories they already have. A flood can be recorded, a riot can be policed, a parish can count the poor. But a continent-scale atmospheric disruption that mutates into hunger, contagion, and unrest does not fit neatly inside one office. So it disappears into files. To be fair, the mainstream explanation does account for a great deal. Tambora absolutely matters. Without Tambora, there is no convincing case for the timing, the haze, the cooling, or the abrupt collapse of seasonal normality. But the single cause version of the story still leaves something out. It can become too tidy. Europe in 1816 was not a laboratory surface reacting evenly to one volcanic input. It was already vulnerable. The early 19th century was part of a colder climatic interval. Another major eruption may have occurred in 1809, adding background cooling before Tambora arrived. Solar conditions were subdued, grain systems were regional, fragile, and often politically distorted by tariffs, war aftershocks, and poor infrastructure. The volcano lit the fuse. The structure of Europe determined how far the blast wave traveled. Official explanations tend to end with the eruption. The harder question begins after that. And when the scale widens, the pattern does not disappear. It repeats. In Britain, the summer turned raw and sodden. In Switzerland, rain fell through what should have been the growing season. In the Czech lands, documentary sources record the cold and the bad grain harvest that followed. In Italy and Hungary, even the snow looked altered. In Ireland, weather pressure fed disease and hardship. These are different landscapes, different elevations, different crop systems, different administrations. Yet the same sequence keeps appearing. Darkened or strange skies, persistent rain or cold, damaged harvests, rising prices, social strain. A single ruined valley could be called misfortune. A repeated continental pattern is something else. Even the cultural traces point back to the same atmosphere. The famous gathering at Villa Diodati, near Lake Geneva, is often told as a literary anecdote. Byron, the Shelleys, ghost stories, Frankenstein. But strip away the romance and the scene becomes evidentiary. They were indoors because the weather would not release them. Byron wrote of a sun extinguished, and he did so in a year when many people were describing skies that seemed physically diminished. Art from the period shows intensified reds and yellows in twilight. Poetry, paintings, and journals are not proof by themselves, but they preserve the feel of the air. They show that the event was not only agricultural or statistical, it was sensory. People could see that something had changed above them, even when they could not name it. This is why the story remained partly hidden. Not because powerful men sealed the archive, but because accepted categories narrowed it. Historians wrote about famine, climatologists wrote about volcanic forcing, literary scholars wrote about Byron and Shelley, economic historians wrote about grain prices, local archives recorded floods, relief, and disease. Each of those records is accurate within its own frame, but the event itself crossed every frame at once. There is inertia in institutions. There is classification. There is the ordinary habit of reducing a crisis to the department assigned to process it. That is how a sky event becomes a harvest event, then a price event, then a welfare event, until the original pattern is no longer visible. What remains, then, is not a tale of one inexplicable summer. It is the outline of a continent briefly exposed to forces larger than its explanations. In 1816, Europe encountered an altered atmosphere and responded with old tools: parish relief, police reports, grain controls, sermons, almanacs, and guesswork. People blamed comets, sunspots, divine judgment, distant earthquakes, bad luck. They were wrong about the mechanism. They were not wrong to sense that ordinary weather language had failed. Summer had not simply been cold. Summer had been interrupted, and that is the unsettling part. The familiar phrase, "the year without a summer," sounds almost quaint now, like a curiosity from the age of candles and coaches. But the archive says otherwise. It says the season failed across multiple systems at once. It says the light changed, the water changed, the prices changed, and then the administrative language changed with them. The pattern was preserved in fragments because no one institution could hold the whole of it. The pattern does not disappear. It only becomes harder to see once the crisis is divided into smaller names. And so the real question is not whether the theory sounds strange, but whether anyone with the tools to verify it has seriously looked.